Hello, everyone. So please take a seat. You guys might want to come a bit further forward. The text is a bit small, so I'm David, and with me is Pierre-Paul, who's sitting here, who's going to be presenting after me. This talk is about advanced animation features in Unity 5. So first thing, quick show of hands. On a daily basis, how many of you guys are still using Unity 4? Higher. OK. And how many are using 5.0? 5.1? Oh, that's a lot. Nice. 5.2? Hey, awesome. So today we're going to show you an example of state machine transition in behaviors, which has been introduced in 5.0. Pierre-Paul is going to show you a Playable API example, which has been introduced in 5.2. And he's also going to show you a live retargeting example, which is going to be in 5.3. So like in the keynote, I'd rather show and not tell. So I will show you a quick example of state machine transition and behaviors. So here I've got Ethan. So in a game, all the time you're going to want to have a single state with multiple animations. In this case, Ethan has 3 attack animations. And you're going to want to play them randomly. You're going to want to choose one of them. So in 4.0, one way you could do it is you could brute force it. And you could have basically a transition from each state, so melee 1, melee 2, melee 3. And you would basically, in your character script, you would set a bool in UD4 and a trigger in UD5 to select a melee animation. So right now, I'm just going to do the script part myself. So this way is a bit intensive because you have to manage all those transitions, and after a while, you're going to end up with a huge spaghetti of transition states. So the other way you could do it in Unity 4 was that you could have a blend tree. So here I've got a blend tree with the same 3 animations, and it is blending between those 3 animations based on this parameter here that you might be able to read. And so what I'm going to do is, if I click melee, then it's going to play the animation. And after that, I have to change the selector to, let's say, 1, and then it's going to play a new animation. Or 2, and it's going to play a 3rd animation. So you could randomize the melee selector parameter to change the transition. This one is a bit easier to maintain because you don't have as many transitions. The thing is, though, one thing that's a problem is, let's say I'm playing an animation and I want to change the blend parameter. You'll see that the animation gets interrupted and gets switched between the animations. It's a bit tricky to get it correctly, especially since you don't exactly know when the animation finishes, when the new one starts. So unless you've got a bit of leeway in between your animations, it's gonna show if you're not timed perfectly. Like this, for example. So in Unity 5, we have introduced state machine behaviors. So if you want to add one to your state, you go here and you click Add Behavior. And you create a new one. I'm going to name it Toto. And if you go in Visual Studio, you will see a list of functions that you can override. So the first one is onStateEnter, which is called when state starts. You've got onStateUpdate, which is called every frame. onStateExit, onStateMove, which is responsible for root motion. This is the equivalent of onAnimator move. And onStateIK, which is the equivalent of onAnimator IK. So in there, you can put any code you want to handle at the start of the state. So you could handle some setup code in there. Or in the update, you could handle, I don't know, anything that has to be run every single frame. And in onStateMove, you could decide to override the root motion just for this one specific state, which is nice. And then on state IK, if you have some really specific code that you want to run the IK in this state, you can put it there. So since I really don't want to change code on stage, I've got an example already set up. So this here is the same state machine as before, but I've got a script set up on the blend tree here. And in there, what I did is, so I randomly select an index between 0 and 2, or 0 and 3 exclusively. And I set my melee selector. Oh, do you guys see that? Oh, no, yeah. Sorry. So what I do is I set my blend parameter randomly on the enter. So if I go back and I say like melee, you guys probably won't see it, but this one is going to change. Oh, it's not. Oh, yeah. There we go. OK, yeah, it changed. Joys of random. So yes, so it's going to select randomly between the three animations in the blend tree. So this way, you don't have to manage the start and the end of your animation in your character code. You just put it in the state. So this way, you don't have to go everywhere to manage your code. Now, also what you could do is you could have a state machine behavior, which is on the state machine. So in this example here, I've got a state machine with an entry transition. Oops, sorry. So here I've got my three states. I've got melee 1, melee 2, melee 3. And I have them transitioning from the entry node here in the state machine. So what you can do here is you can select the entry. You can make a transition to a state. And it's going to take this transition based on conditions. So for example, in this case here, which you probably don't see, it's going to transition on melee 2. And this one is going to transition on melee 3. And then after that, after this animation is played, I have a transition to the exit node. And this transition is going to happen at the end of the animation. Right now, it's at exit time 0.88. So if I go back here and I press OK, yeah, sorry. And then the condition here to go in the state machine is that I have pressed my melee trigger. So if I go in here, I'm going to play an animation. So right now it is randomly being chosen because I have my state machine script on my state machine instead of the state in the blend tree. So if I stop the link. So the state machines have the same functions as the states. But on top of that, they have on-state machine enter, which is overridden here, and on-state machine exit, which you can use the same way as on the state. So if you have a sub-state machine that's responsible for doing all your melee code, for example, well, you could set up your melee collider to enable. You could pretty much set up anything that is valid for this whole group of states. So in this case, what I'm doing is when I enter the state machine, I do the same random code that I did before. But instead of driving a parameter, it actually selects a trigger randomly between the three triggers that I have. So also, what you could do with the state machine behaviors is you can have one on-state enter, on-state update, and on-state exit that's valid for all your states in your state machine. So instead of copy-pasting your code from state to state, you could just put it here. And also, that doesn't override the fact that if you have one on your state, it's going to be called on your state too. After that, we can get fancier. So here, I've got a state machine where I made a sequence of animations. So it's basically melee 1, melee 2, and melee 3. So in here, what I did is on the sub-state machine here, I added some code in the on-state machine enter. And what it does is it shows a weapon that you saw before, well, weapon, the popsicle. And on the state machine exit, I added some code to hide it, which is really, really useful. So this way, all my weapon code, all my melee sub-state machine has its own code handled in there, and I don't have to worry about it anywhere else. Also, what I did, the other thing I did is that the third state, which is supposed to show particles, seems not to be showing them. But basically, what you could do too is also enable particles or any other effects that are not showing right now in your state. So here, I have set my onState enter to go in a component that exists and set something active that I set up before. So one thing that's nice is in all those functions, what you get as the first parameter is the animator. So what you can do from that is you can go and get the game object, and then you can go and get any component that you would like to use on your game object. One error that a lot of people do is that they try to feed that from the scene view, and they try to push things in the state machine behaviors. The thing is, the state machine behaviors only get instantiated when you actually start playing animations. So the right way to do it is to have something where you would add a parameter, a member on this class, and on the first time you call the function, you go get the animator, you go feed whatever you need, and then you keep that locally so that you can use it later. And the last thing I did too is that so right now I'm just clicking. Oh yeah, so apparently my thing is back on. Weird. So Pierre-Paul, I blame you. Yeah, so also I put some input code in the top layer here on my top state machine. So instead of having, I mean, this is not a great example because it's super simple, and all it does is it checks for a click on the mouse, and it just sets a trigger for melee. But it still shows that you could decide to process your inputs in your state machine code instead of processing it directly in your huge character script that gets bigger and bigger and bigger. So I think that all of this helps you keep your code local and keep your code manageable and help you also track how what states are playing, which was super hard to do in Unity 4. And make sure that you have like perfect cues on when states start and when they finish, which is really, really important when you have character actions that you want to do. So, and that was about it for my part. So I will leave the floor to Pierre-Paul, and we will be answering questions. So if you have any questions about this part, we're going to answer them at the end. Thank you.
Thanks, man. So, hello, everybody. Very happy to be here today. I hope that you're excited by what David showed you. I hope that you're using, actually, this stuff. If you're using Unity 5.0, you should definitively use what David showed you, the state machine behaviors and the state machine transition. I think they're very powerful, and it kind of helps simplify your state machine and all your animation logic in your game. So today I want to talk about something that is really new in Unity. In fact, it just came out in 5.2, and it's called the playables. Just a little bit of backstory behind the playables. So the first thing that we wanted to do is something that I think that Mecanim was lacking, and I think that you guys told us that it was lacking. It was openness, because you know Mecanim has this big Animator controller, which is the state machine with the layer and everything, but it was really a black box. And sometimes, as user, what you want to do is only to be able to just please play this animation right now, please play this animation at that time, at that speed. And you know, it was a bit complicated with the state machine behavior to do that. It was possible, but it was like a big overhead. So this is something that we wanted to fix in the animation system. So we started discussing about how should we approach that. And you know, in the Montreal office, we also have another project that we're working on, which is called the Director Project. I don't know if you guys heard about it, but we spoke about it, I think, last night or in GDC, I don't know. So we already did a couple of demos around this, but basically, the Director Project is a big name for a project that we have in Montreal that will make it so that it's easy to play with animation, to play with audio, and to play with other subsystems in the same manner. So this means that we wanted to have an API that is common to audio, to animation, and to video. So we sat with the audio guy, we sat with the video guys and the director team, and we started to discuss what should be the way to address this. And by working on this, we just thought that the best way for us to represent those systems, to give like a kind of a command buffer to those systems, is to use graphs. So this is where we had the idea to do playables. So basically what playables are, it's a way to create graphs. Currently, it's something that you create at runtime, and it allows to specify how you want to blend your animation. So again, this is a first step. We are releasing this in 5.2 in an experimental API, but we want you guys to play with it and tell us what you think about it so we can improve and so we can be proud of ourselves because we did that. So in 5.2, it's only animation that uses the Playable API, but going forward, we're going to add the audio. There's already some audio guy working on this as we speak, and we're going to use this for other, I'd call them complex playable, like for sequencers and stuff like that. This will be the baseline for everything. So we're very curious to hear your thoughts about this, and I'm going to show you. I'm going to sit on the computer and show you what we have in 5.2 right now. Oh yeah, so I have fancy words to explain what it is, so I will read them out loud because I actually wrote them. So it provides programmatic access to Mecanim using a scripting API to make arbitrary graphs. So you can use your imagination and say, oh, I can do dynamic blend tree. Oh, nice, I can now blend between state machine. So this is what you have right now. We also want it to be very extensible, so you can make your own custom mixers, and I'm going to have example for that. And we also want you guys to be able to do procedural animation effect. So I know this is very exciting, but that part is coming soon. I will be working on it when I come back to Montreal. And again, this is not just for animation. While we design everything, we wanted to make sure that this is going to work with other systems. So it's very important for us to get this right. So this is why we're releasing it as experimental, so that we can and we will change it a little bit in the future version. But you know, we'll take care of you guys so that you don't have to trash all the work that you did in 5.2 so that it doesn't work with 5.3. We're going to find an upgrade path that is meaningful. Blah, blah, blah. Enough talk. Let's go see a demo. OK, so let's just start. Oh, you have the layout saved?
The layout is in Boston. Called Boston.
Oh, Boston. Yeah, that's my layout. Thanks. OK, so here I have the same dude that you saw before. I have a series of scripts here that I'm going to show you guys. So here, classic case, and the case that was, in my opinion, a bit too complicated to do before, is to play an animation. So it's weird to say. But let's go take a look at the script. Just shut it down. So here is the first building block for the Playable API, and it's called the animation clip playable. So what it is, basically, it allows to instantiate an animation clip and put it into your graph. So why is it something that has to be instantiated? When you think of it, it's not like there's the animation clip, which is the constant data, which is curves and stuff like that. And the instance is more like this is the time that is going to be played, and it's the speed that it's going to be played at. It's a bit similar to what was called, I think it was called the animation state in the legacy system. But let's not talk about the legacy system. So here, I just did a small thing in the update function. We have so there's a mode where you can say to your playable, just play. So this will automatically increment the time. And here you're able to give a speed. So that's a way to use it. Or the other way is to leave the play state on paused. meaning that time will not advance itself, and you drive the time manually. So you know this is interesting for scrubbing, for precisely controlling animation. This is for other simpler thing. How does it work? So here, like on the start of the script, what I do is I create a new playable like this, and I just tell again, we wanted to keep the same component. So you take the animator component and you just tell the animator component, play. So you know I did 2 lines because I wanted to make it look professional, but it could be done in a single line of code. So if I press play here, by default I just made it so that it's in autoplay. So here I can change the speed. I can set the speed to negative, which is like I can imagine that when you do door animation, you can just do a simple script that just does the back and forth like this. So that's one thing. And then there's this here. I go drive the time directly. So here, you know, I'm just driving the time directly. Yeah, so this is for the basic thing. And it's fun because you don't have nothing to prepare. Like you don't have to have like an animator controller, state machine set up with all these animation and states and stuff. You don't have, like in the legacy, you had to tell what animation you're gonna play for it to work properly at least. So now you just take the animation and you play it, please, and it's gonna play right away. Yeah, so that's the simplest case. Let's get a little bit more advanced. So here I have an animation tree. So here we see the second building block. It's called the animation mixer playable. So a mixer, it can be seen as a blend tree. It's basically you have any number of child, you connect them as an input to the mixer, and then you set the weight. So here, again in start, what I do is that I create a root mixer. I call it idle run because it's going to mix between being in an idle animation and between another mixer that has run forward and backward. So you see these are the 2 mixers that I will instantiate. And then I add the idle as the first input. I add the back forward, the second mixer as the second input. And then I take the second mixer and I just add those 2 animation. And then, so you see this code here is basically the setup of my animation graph. And here, I take the animator component and I tell it, please play the root of this graph. And then in the update function, and this is fancy, we have something called the graph visualizer. So this is on GitHub. You can get it right now. It's completely like you have access to the full source code. So you can improve it and make it so that it's more useful to you guys. And you know what? I tried it for this demo, and I ended up going in the code and changing stuff so that it better suit my need. But it's super open. It supports many things. I'm just going to play it so you're going to see what I'm talking about. So you see here, this is the graph visualizer. So the way it works is that in your update code, you just tell the graph visualizer, show me the playable graph that starts with this root, and give it a random name. I don't know, like, yeah, we have a name here that just says something. So here you see that you can actually debug your animation tree. So it's really easy. This is something that we've used while creating the Playable API. So it was fun to have this visualization tool to just help us know what's happening. And I'm going to just play a bit with this. So here, this is the first parameter I published on my script. It's called run, but basically, it will change the weight values for this first node here. So see that. It's going like this, and then all the weight is going to this one, to this leaf here, and this leaf here. I guess it's hard to read from out there, but here it's written backward, and here it's written forward. So I'm just like moving back and forth like this, changing that, going back to idle. So you know, I really hope that you like our state machine in Mecanim, but if you don't like it and you want to do your own state machine, this is what you want to use. You want to use this system so you can build whatever you want with it. Yeah, you can also even do your own playable mixer. I'm going to show you an example of that. Yes. So the crossfade playable, for those of you who've used the legacy system, you might know where I'm getting at. So here I just derived from the mixer playable I showed you before. I have here some settings that I use. And I have a function that is called crossfade that is public, that is going to be called by game logic or something. So in this example here, it's a crossfade call. You specify what animation playable you want to transition to crossfade to, and then there's a duration. And the nice part here is that you're actually crossfading to an animation playable. So you know this animation playable can either be an animation clip playable, which I showed you at the beginning, but it can also be a mixer playable. So you can really do whatever kind of logic, and this kind of come closer to being a state machine when you have transitions like this. So when this happens, I just add a new input and I start the transition. Then we get to the part that is a bit more, I would say, tricky, but we have something that is called prepared frame. And this, you know, you're not forced to use that. It will work if you don't use that. If you don't use it, in certain cases, it will work. But it's just the right way of using the playable system. So basically what this is called by the graph evaluator in each node in the order they are traversed. So this means that if you have tons of those custom playables like that, you don't want to handle all the logic in a big update function in a script somewhere, right? You want to have like the waiting logic being handled by the custom playable node itself, and this is what is called prepare frame. So, and you know, I hope that you guys will do all kind of crazy nodes. You know, I'm sure that there will be like tomorrow somebody that just writes back the whole legacy system using playable, and this is possible. And if you want to do something like this where you just connect multiple playable together, you will have to do it in prepare frame. Otherwise, you will really, you will be in hell. It will be too complicated. So prepare frame, super simple function here. I compute time on whatever blah, blah, blah thing. And then I set the weight. So this is while I am in transition, you know, so one is lowering its weight and the other one is his weight is growing. And then when the transition is done, I just clear my input and I reparent my childs accordingly. So let's just take a look at that, shall we? Oops, it's not a good one, just give me a sec. Boom, boom. And I press play. And then he's in idle. And he will run forward, and then he will run backward, and then he's idle, and then he'll go forward. Let's just pause this. So you see here, he's actually going in his forward animation, and he just started playing the backward animation. So I'll just kick in the frame like this. So you see, like, I don't know if you see the color changing, but if you don't see them, imagine them. Here it's getting grayer, and here it's getting whiter. So you see it's doing that. And then, poop. You see, we're fully going backwards. So it kind of took care of tidying up and removing the connection and stuff like that. And I think that this is how you ideally would do a transition graph, right? So that's it for crossfading. But you know, now we're super happy because we have like this low-level control thing that can do transition, custom mixing, and whatever. But you know, there's such power inside of the Animator controller in the Mecanim state machine that you want to use. So the idea that came to our mind is that we want to take what is called the Animator controller, which basically is the instance, and put that inside of a playable. So this means that we have another type of playable, which is called the Animator controller playable. I'm going to show it to you. Again, you're going to see how simple it is. So here, to create a controller playable, which again, just to recap a little bit, when you create a playable, it's in fact an instance of an asset. So like we had this for the animation clip, you would instantiate an animation clip inside of your graph. But now in this case, what we want to do is that we want to take an Animator controller and instantiate it in your graph. So this is super powerful. This means that you can transition between state machines. This means also that you can have state machines that are part of a level or part of the environment, or even better. It means that you can have, and this is a dream for me to be able to do that, is that you're able to have, like using Mecanim's retargeting, you're able to have the props in your game that actually tells your character, or any character, how they should use that prop. So this really works well also for DLC and stuff like that, because it comes with the asset, right? So if you have this gun, you have this new gun in DLC, it comes with its Animator controller that just tells your character how to hold it. And then you're able to transition back and forth to to that state machine. Another good example I have is like for swimming. You know, you have one level of swimming in your whole game, but you always have in your character state machine this huge sub-state machine that handles swimming. And you don't want to do that. It doesn't make sense. Or you don't want to load all the swimming animation for every single level in your game. No, you want to load it when you load the level. The water in your level, right? So what happens is that when you go into the water, it transitions to the swimming system, and it works. The thing also that is nice is that the API for this guy here, the controller playable, is the same as the animator. So you're used to using the animator, like you just do like set trigger or play this state or transition to this state. All of this is all available to you, so you can still drive your state machine the same way that you did before. And even like as a bonus, because we don't want you guys to just change everything, you can still call those on your animator itself, and it will trickle down the calls to your subcontrollers that you have out there. So it should be really easy to just switch to this approach. So let's see an example of that. So I'm going to put a weapon in there. Yeah, I don't know what we have with using popsicle as weapon in Mecanim, but yeah, it must be something in our culture, I don't know. So here I have this super bad weapon here that I've attached to it a script. And you see, as a member of this script, there's a animator controller. I'm going to take a look at it. Right, it's not the good one. This, yeah. So here I have 3 animations. They're very similar. No, they're identical to the animation that David just showed us before. So this is like fighting animation. So the way that I did this here, and it may not be the most optimal thing to do, but still, here I have, oops. So here I have a trigger enter callback. When I enter, I just get some component that I have on my hero guy, and I just tell him transition to. Let's go take a look at what does transition to do. It's really simple, actually. Transition to, what it does, it receives the controller from the weapon, the one that it was a public member of the script, and it uses the crossfader playable, and it's just called crossfade, like I've shown you in the previous scene. So here, let's press play. Let's press pause first. So here, a couple things that are interesting here. First of all, so I wish that live link worked, but imagine that live link would be working. Because I don't have the good one playing. Let's start again. Give me a second here. Like this. And then? Okay. So what I have here, I have the character that is, in fact, I have this playable graph here that has a crossfade playable. I've shown you before, it's to do a transition. I have this node here, which is an animator controller playable, meaning that it is really a full Mecanim state machine. That is playing here, so you see like there's a live link. It was in idle originally, and now it's running, so you have this thing. So you know, eventually, I would like to be able to just dig inside of this graph and see this view here, but it's coming. And then let's go like this. And boom, it started the transition here. So you see that now it's still playing the simple locomotion controller, but it's going to the weapon controller. And then at the same time, I can just go like this, and I see the live link also to this guy. And then he's just like playing the state machine. So yeah, you see that now it's possible to do transition between state machine. I hope that you see the power in that. I'm very excited that at last we can give that to you guys. So yeah, try it and tell us how it goes. So for the last part, I want to talk to you about something that will allow retargeting for live mocap, or for, I'm sure you guys are going to think of some crazy thing that you can do. But this is a very simple API that we've added just recently in 4.3, which will be like, we release like crazy right now. We release every 3 months, so we just released 5.2, and it's going to be like in 3 months, you're going to have access to that. So let me show you how simple it is. So here I have two guys. I have that guy here that has an animator controller. So it's playing an animation. Those two characters are humanoids, meaning that they use our retargeting system. And we have this guy here, which is some guy. But he doesn't have anything. He doesn't have an animator component. He only has a simple script. So let's take a look at the script. So here, this is what does the magic sauce in this system. It's called a human pose handler. So it's a fancy word that just tells that it allows you to transfer what we call a human pose. And a human pose is, in our retargeting system, we don't use rotation, we don't use transform, we use human pose. And we have some glue that is called the avatar that takes the transform and that converts that into a human pose. And we have the opposite, a human pose that is written into transform. So this is how Mecanim works internally in the evaluation of animation. But what we wanted to give you guys is exactly this ability, is to take a number of transform and just take that and make that a human pose. So meaning, if I say transform like that, but imagine that it's the source is from a mocap. You're in a mocap studio. You're feeding transform directly into your character. You want the pose handler to take this transform hierarchy and just give me a human pose for that. And then you take this human pose and you write it to a destination character. So if I own the mocap studio and I was doing mocap, I would have a skeleton in my game that would have exactly the same proportion as the actor that I have in my studio, and I would be able to, while we're feeding this inside of Unity, I would be able to see how it actually looks into this little fairy or gremlin that I have in my game that have completely different proportions. So this means that when you're directing your actor on the set, you can give him hints of what to do or what not to do because you know it's not going to work well with a fairy. So this is a very powerful thing that we wanted to have for a long time, and we made it as easy as possible. So here's the example of how it works. So here on initialization, I just create the human pose. So this is the data that will be passed between the source and the destination. I create the two handlers. So this is the source one that gets the avatar from the source, the root transform from the source, and the destination one, this is where we actually want to retarget to, and then we take the avatar, we take the transform. So this is all the setup needed. And then in the update function, what I do, I take the source handler, I tell get me the human pose. So this really goes into the transform hierarchy, reads them, converts that to human pose. So now you have something that is retargetable, and then you take that and you put it on your destination. So 2 lines of code. I don't think it gets simpler than that to do retargeting. So if I press play, well, of course, you see 2 guys that are doing exactly the same thing. So this guy here is actually playing a state machine animation, an animator controller animation, and it's being retargeted in a live manner into that guy. So I can show you more uses to that. So here it also retarget look at. So here, I don't know if you guys played with that, but with Mecanim, it's super easy when you have a humanoid character to do look at. I'm just going to show it to you because we have time. So here, I just have a callback called onAnimator IK. If there's a game object target that is not null, I just tell the animator, look at this position, and I set the weight. And what is nice about our look at, I hope you looked at it, is that you can specify different weight for the head, for the neck, and for the chest. Here I just put 1 there because it's the default value, and we're just going to ramp down the weight for the other, the head has all the look at, and the neck has a little less, and the chest a little less. So yeah, I just do that here, and if I move this little sphere, the sphere here is the IK target. So if I move it around, you see that the other guy is saying no as well. So this means that also it works with IK. And what is really nice is that I can completely stop the animator. It doesn't need an animator to run. So here I have this guy here that has an avatar that has the glue to convert transform into a human pose, and I just write it into this guy. And an example of this would be let's just go down here. Oops. I think this would be interesting. So you see here that I am using Mecanim's retargeting system to move its hand. Like, I know it's boring because it's just a hand that is moving, but imagine that it is a mocap suit, and it's really mind-bogglingly nice. Is that a word? So, so yeah, that's new thing that's coming in for 5.3. So again, let me reiterate that I want you guys to play with our playable system in 5.2. Like, just bust it open, tell us what is right, tell us what is wrong with that. We still, since it's an experimental namespace, it's stuff that can change. So we're really, really open to your input. And yeah, I hope that you're happy with it. We're really early, so if you have questions, whatever, you can just ask them. We have 2 microphones in there, or you can just, if you're shy, just come and see us after and we're just gonna answer your questions.
Also, I know I ran through really fast on the state machines. I was pretty much afraid to modify anything and break anything. So if you guys don't have any questions, I can show you more in depth how it works. I mean, do you guys have any questions? It doesn't have to be about those features. But yeah, you just come up to the mic and we'll answer them.
Thank you for the presentation.
Thank you.
So a few years ago, I was using something called the Gamebryo animation tool. And as an animator, one of the things that I found really nice about that is that within the animation software, we could attach tags to things like when a left foot is down or a right foot is down, export that animation, and then the Gamebryo tool would actually create the blends based on those tags. So we could use our eye as an animator, say this would be a good point to have a transition, create it, and then the software would recognize it and make sure that there was a seamless transition. And I was wondering if there were any plans for something like that.
So currently, I just don't want to say to tell a lie, but I think that currently with tooling, you're able to do that, but you have to do tooling, right? So the thing that has to happen is that you have to have someone that writes a script that, oh yeah, we have to modify, yeah. You have to write a custom importer to import those tags, right? So I don't know what it was in Maya, but I guess it was like special bones, or what was it? A custom property that you added. So yeah, so you have to have like your custom importer that I don't know about the extensibility of our importer, but I think it supports that. And then you have like to post-process. So this is like very code-heavy stuff. So it's possible. It requires a programmer in your company to do the tooling for that. And until then, like we certainly don't have like short-term plans to do that. But it makes sense. I agree with you. It makes sense, but we just don't have it yet.
With the human pose animator, what is the best way to incorporate something like a tail or wings or something along those lines? A separate animator, or
I would just add you can add a layer. This is what I would do. I would add a layer on the same animator controller and just drive the animation from there. And then when you move the poses from one to another, you just it will work if the tail are like similar, like same length, and you just take the rotation and map it to the other one. It's not retargeting, it's the dumbest kind of retargeting possible, but this is how I would do it.
Thank you.
Cool.
Hi.
Hi.
Hello.
For the playables that you were just talking about, I was wondering if we want to do something more advanced, like maybe simulate what we would do in a regular Mecanim state machine, like if we had transitions or if we wanted to do things like looping motions. Is there anything we could maybe dynamically build with the playable? Basically simulate what we would otherwise build in an animator, but instead of having to manually pick out thousands of states, if that's what we want to do, just dynamically build it with just playables. Is that something that's practical to do with, again, with looping and triggers and whatnot?
So, unless I'm not understanding the question properly, just tell me, but what you want to do is to use like the looping and the events of the Mecanim system without using the state machine, right?
Yeah, because there's just so many states that would need to be managed.
Yeah, okay, so it's possible right now. Like if you have animation events in your animation and you put them in a animation clip playable, they will be fired like any other animation. The looping is there, the retargeting is there, like everything is there, and it's just like when you play a animation clip playable, everything should work like that.
Great, thanks. And how about also props? Let's say we wanted props to be animated in sync with the characters. For example, maybe a ball deforming as he sits on it, or a band And Ben, scratching, you mentioned things like an animator controller playable, for example, as like a sub-machine. Could you also do that with like sub-playables? Could you have sub-playables playing?
It's a good question. So you can have, like, you can do, like, for that, if it's like parts that are, separated into the hierarchy, I would just have, it can be like two child of the same mixer, and they're like mutually exclusive, so you can just put a weight of one there. But I would have to try to be sure that it's not broken. It should work, right?
It should. I mean, as long as you don't try to animate the same thing at the same time, it should be fine.
Should be fine, yes.
Okay.
But I haven't tested it, so
Yeah,
I'm
we
not,
haven't tried it.
I'll try it out.
But it
Thank you
should
very
work.
much.
Thanks.
Cheers.
Hi. So with the state machine behaviors, you said that it wasn't instantiated until it enters the state.
Yes.
So is it getting destroyed afterwards? And if you change states a lot, is that going to cause?
It's not going to get destroyed until the game ends or the controller gets unloaded.
Okay.
Yeah,
So-
it's not when it starts the states that.
No. It's when the state machine plays for the first time. You know, when you press play on your animator, it's going to take the controller, instantiate all the state machine behaviors, and they're going to be alive until this object gets destroyed.
So you don't have to worry about chop or like garbage collection happening.
No.
Hi there.
Hi.
Hello.
I noticed you were showing the look at function. I was wondering if there's any changes in that, and if you can target specific bones, which are not the head or chest, like arms, if you want to do that.
No, so this is not possible at the moment, but like we are working to open our IK path. So there's many places we're working on to improve our IK path, but one of them is to have like custom playable. This is something I talked at the beginning, to be able to directly go into the animation feed and change values. So this is something that will allow you to do your own IK system, or that we can give you improved IK. So this is coming part of the Playable API, and we also want eventually, and this is on our roadmap, we want to be easy for you guys to create custom rigs with your own constraint, own IK chain on it. So this is something that is like in the labs. We have this, we started developing there. It's not like in a product yet, but we want to have it like, it's in our roadmap, I think, post 5.4, so, but it's coming.
Thank you.
Thanks.
Hi.
Hi.
Are there any plans on tools for giving the developers more information on using root motion with generic rig? Because sometimes I feel like it's lacking.
Yes, it's the poor child. Yes, I completely forgot about that problem that we had. So we should, like you're talking about like the speed and the.
Just information about the transfers, because you can have access to that using more or less like unsupported APIs. So
Yeah.
you can play the animations and see where the transfers
Yeah.
are. But it's definitely way behind. Like with
Yeah.
human pose, you just have that for free.
Exactly. So yes, and I'm gonna take notes. So it's super easy for us to do that. It's just that we haven't, because you know that I don't know what version we brought that, but we have like you're able to specify your own root motion for animation clip using generic. So you can specify which bone to use for root motion. Like since we have that, it's like easy for us just to compute it as if it was a humanoid character, right? So we should yes, we should do that.
Thank you.
But I don't have a ATA or promise, but I'm going to write it on our roadmap that we should do that.
Hey, I just have a really basic question. So when you're trying to debug your animations in the Animator panel, one of the real frustrating things is you can't zoom in and out.
Yes.
Is there any plans for that?
Yes, but so our excuse is that the framework that we use for that, it's impossible to make it scale. So, but we have some guys on the director project that are completed the framework to do like visual programming and stuff like that, and they're doing the zoom, and we're going to steal that from them. Because it's really like so I know that they're working on that, but I don't have an ETA, and I'm by the way, I'm sorry about that we don't have zoom in the anime. And there is like I give you an excuse, but there's no excuse. But yeah.
Just like that, and one of the other things that really breaks the speed is that once the animator is playing, and you're trying to see all the animations, it keeps changing position. You can't. It's hard to see which states are actually playing.
So there's a button here. This guy here.
The auto live link button?
Yeah, just disable this.
Okay, I didn't know about
There's
that.
this
Thanks.
little button here. Like
Put it-
David did
I'll
it,
show you.
David used that many times in his presentation.
Yeah. So basically, I'm gonna put that bigger. I'm just gonna start my scene and show you. But yeah, you can disable the live link, and you could see and debug your stuff, and it shouldn't be a problem. So let's say I've got Ethan here, and Ethan is playing an animation, and if I've got live link, for example, I go. So he goes in the state machine, but I don't actually want to see that. So you can just disable this, and you can go back to this layer. And you will see that this state machine is actually playing right now. And if I switch to another one, or another one, it doesn't bother me anymore. So, I mean, ideally it would be nice to have two different views, one that's like not linked and one that's linked, but I'm not promising that in any available
Was
time.
that the problem you were talking about?
Yeah. Okay, awesome.
So fixed.
That's the kind of bugs I like.
So kind of a follow-up to another question. Is the idea of the Playables API more to add and remove states during, like at runtime, or at the beginning, or what's the right time, or what is the right amount that we can actually add and remove stuff?
Yeah, and this is something that will improve. I think that it's still a bit costly to add some like when you add an animation, like there's no magic. We have to build like some acceleration structure so that we're able to quickly read the data and write it to bone. There's a cost. I don't have like a clear number of how much like millisecond it costs to do that, but it's sure that the more animation you add to the graph, there's a cost to that, right? So. So this is for the Playable API. We don't have plans to allow, at this moment, we don't have plan to be able to change the state machine at runtime, because everything has been like packed into tight data and it's not made to be rebuilt. But as for the Playable, like the tests that we did, they were like sufficiently fast, whatever that means. But we are going to improve on that. The way that we see that is that once an animation clip has been added, we like the acceleration structure, we just rebuild it minimally. We like have iterative rebuilding, and this we don't have. Currently, we clear the structure and we build a new one. But anyway, I'm going down the technical details, but it's gonna work. It's gonna be, I think it's fast enough, but we're gonna make it faster.
So just to elaborate a bit on your question, it's not the point per se of the system. The whole point of the system is really to just enable you guys to, well, basically, I've seen people tell me at the other Unite, oh yeah, I don't want to use Mecanim, I want to use Legacy because it's simpler. Oh, I said Legacy, sorry. But yeah, so this way you can basically make your own state machines. You can do whatever you want. That's the whole point of it. As a bonus, you can actually add animations at runtime, but that was not the main driving force. And as for performance, in 5.2, it will be, I mean, it should be faster in further iterations. In 5.2, it's kind of costly, and if you do it often, it's probably going to show. If you have a lot, especially if you do it on a lot of characters, because we rebuild everything, but there's a lot of space for optimization there, so it's going to get faster.
Yeah, you know, so just like a trick, like our state machine uses that internally now, and the state machine internally like creates this playable graph, but we always instantiate all our clips so that it goes, but not all, but instantiate like a lot of clips just to help us to go faster.
Yep.
So what, at what time are we is it recommended for performance reasons to create the graph?
You should do it all at once as much as possible. There's no particular time, you know, as in your lifetime of your game, or, you know, lifetime of your game session. But you should probably do it all at once, because after that, each time, if you run it and then you add and you run and you add, it's going to cost every single time. So the best thing you could do is just add a bunch of them and mute them. Set your weight to 0. So this way they won't play, they won't cost much, but they will be all allocated, which is exactly what we do. Also, one thing that we haven't mentioned about the playables, we have made really great improvements on memory footprint because it's a lot more dynamic.
Yes.
So it should be, your running animators should be a lot less costly. You should have a lot more headspace for your art.
Yes.
Because artists never add more stuff.
Like insanely smaller. Like I won't tell the numbers because yeah, we're really like smaller in memory footprint. It's
yeah. Do you guys have any other questions about the director? Maybe. I mean, it's a new feature. It's gonna be awesome. Oh. Yeah.
Hello again. Sorry. So another question that had occurred to me is, for those of us who are still stuck in 4 point whatever, that are looking forward to some of these features in 5 or 5.2, if we, when we upgrade to that, what negative effects might that have on existing Animator controllers and transitions?
Animator controller?
Like, there should be none. Like, there's none known problem of upgrading. Your asset from 4x will load in 5.0,
Yep.
5.2.
All transitions intact with
Everything.
Okay.
Otherwise, it's a major bug.
Yes, and
Yes,
that's
so-
sort of related to the second part of this question, and that is the ability to copy and paste transitions with conditions on them would be greatly appreciated.
We've got two
Some point.
branches that take two different approaches to that. We haven't got around to cleaning them up. But I made one copy-paste just to do my presentation at the other Unite because I was fed up with it. So yes, it's coming at some point. No TA because we have a lot of stuff to deal with, but it's coming. It's coming.
Yeah,
Thank you.
And you can, by the way, maybe in 5.0, we have an API to create your state machines.
Oh yeah.
Via script. So if you want to do your own tool that builds stuff over it, you're able to do that.
So one thing you could do is you could have an Excel sheet of states by end states, and just you have data for you. Like there's a transition there, and then this is another cell, and then you have this code, this thing that just reads your Excel and will spot out a state machine. If you
Excel sheet.
want. Oh yeah, CSV. I've seen that.
Yeah,
Thank
I've
you.
done that.
Any other questions?
Just another thing I just want to add to that, sorry. Like an example of things that people are doing with the state machine API is that they aggregate state machines. So they have, like, instead of having like this very complex state machine that they build by hand, they have different people working on different controllers, and then they have a script run that just aggregates them into a single controller. So this is another example.
Well, if there's not any more questions, we are really happy to see all of you guys here, and we hope you enjoyed it. And I hope you have a great Unite.
Thanks, guys.